MS Ramaiah University of Applied Sciences.
Hello friends, with this experiment we are determining the crushing value of given coarse aggregate. Apparatus: cylindrical measure of diameter 11.5 cm and height of 18 cm, steel cylinder of diameter 15.2 cm and height of 14 cm, square base plate, plunger having piston of diameter 15 cm and height of 11.5 cm, steel tamping rod of 1.6 cm diameter, weighing balance, compressive testing machine, that is CTM. The principal mechanical properties required in road stones are satisfactory resistance to crushing under the roller during construction, adequate resistance to surface abrasion under traffic. Aggregate used in road construction should be strong enough to resist crushing under traffic wheel loads. If the aggregate are weak, the stability of the pavement structure is likely to be adversely affected. The strength of aggregates assessed by aggregate crushing test. The aggregate crushing value provides a relative measure of resistance to crushing under a gradually applied compressive load. To achieve a high quality of pavement, aggregate possessing low value should be preferred. Procedure: sieve the aggregate through 12.5 mm and retained on 10 mm IS sieve for standard test. The aggregate should be in dry condition. Then fill the aggregate into cylindrical measure in 3 layers of approximately equal depth, each layer being tamped 25 times by the tamping rod. Struck off the excess aggregate on the top of the cylindrical measure using tamping rod. Note down the mass of aggregate along with the cylindrical measure. Let the mass be W2 grams. Transfer the aggregate from the cylindrical measure into the cylinder of 15 cm diameter. The test cylinder should be filled by the aggregate in 3 layers by tamping 25 times for each layer. After filling the aggregate level, the surface of the cylinder, the plunger is placed on the level surface of the cylinder. The test cylinder along with the plunger is placed on compression testing machine. Load is then applied through the plunger at a uniform rate of 4 tons per minute until the total load is 40 tons and releases the load. Aggregate after crushing are removed from the cylinder and is sieved through 2.36 mm IS sieve. Weigh the sample which is passed through the 2.36 mm IS sieve. Let the mass be W3 grams. Weigh the empty cylindrical measure. Let the mass be W1 grams. Repeat the above procedure for 2 more samples. Aggregate crushing value is expressed in terms of percentage. Calculations and observations in terms of weight of empty cylindrical measure, weight of empty cylindrical measure along the aggregate, weight of dry aggregate, weight of aggregate passing through 2.36 mm IS sieve, and aggregate impact value in percentage is calculated.
Hi students, as a part of Concrete and Highway Material Testing Laboratory, today we are discussing an experiment called as aggregate crushing test. Okay, I am going to go with 3 different stages in this experiment. The first stage I will just give you an introduction about the apparatus. The second stage I will explain you how to do the sample for doing the crushing strength. Third, we are going to do the crushing strength for a sample of aggregate using a aggregate compression testing machine. The apparatus required for conducting the experiment are the weigh balance of 1 gram accuracy, the IS sieve sets of standard size, that is 12.5 mm, 10 mm and 2.36 mm. The third is a tamping rod of 16 mm dia, and the fourth one is a measuring cylinder. It's a measuring cylinder of dia 11.5 cm and height of 18 cm. And next apparatus is the testing cylinder, which is having a diameter of 15.2 centimeter and a height of 14 centimeter. The next is a plunger, which is having a diameter of 15 centimeter and a height of 11.5 centimeter. It's also called as a plunger piston. The last apparatus which is required is a base plate, okay, where we are going to fix the testing mold above the base plate. The second part of the experiment is the conduction. So I'll tell you how to do the experiment. First, what we are going to do is we are going to take up the standard IS sieve 12.5 and 10 mm, and we are going to take some aggregate in it, sieve the aggregate. I want the fraction of aggregate which is passing 12.5 mm and retained on 10 mm IS sieve. Take the sample of aggregate, put it on 12.5 mm sieve, sieve the aggregate fraction, take up the aggregates which is passing 12.5 and retained on IS 10 mm sieve. After sieving the aggregates, the next step is we are supposed to take up the empty weight of the measuring cylinder. So what we will do is we measure the empty weight of the measuring cylinder. It's 3701 grams. We call it as W1, that is the empty weight of the measuring cylinder. After measuring the empty weight, what we will do is we are going to place the aggregates in 3 equal layers to the measuring cylinder, and we are going to compact each layer with 25 number of blows. So I place 1/3 layer here. What I am going to do, this is a 16 mm tamping rod. I am going to place this 25 number of blows so that the blows should be uniform across the 1/3 layer. Make sure that you are placing 25 number of blows. After the first layer, repeat the procedure for 2 more layers. So compact the second layer with 25 number of blows. At last, place the third layer. And repeat the procedure by giving 25 number of times to the third layer. After completing 25 number of blows, check for voids on the surface, add the additional material required, don't tamp it, just scoop a layer using the tamping rod. After preparing the measuring mix, what we are going to do? We are going to take up the weight of the measuring cylinder plus aggregates. We are going to note it down as W2. The difference between W1 and W2 gives you the weight of aggregate which is present in the cylinder. Our measuring aggregates is done. The next is experimental setup. So we are going to place the testing cylinder on the base plate. Whatever the measured aggregates will be transferred to the testing cylinder. So after transferring this, make sure that the aggregate will be uniformly spread, and we are going to place the plunger above the system. We should make sure that this plunger is in horizontal level, and this is what the experimental setup which is required for doing the aggregate crushing strength. Then now the test setup is ready. we are going to take this mold and we are going to place under a compression testing machine. Now we are near the experimental procedure of doing the aggregate crushing test. So this is what we call it as a digital compression testing machine. There are few operations in the digital compression testing machine. Okay, so what we are supposed to do, we are supposed to put it in an axial mode where the load is applied along the vertical axis. So now we are going to place the setup onto the compression testing machine. Cylinder is placed on the compression testing machine. Now we are placing the plunger above the thing. Now the experimental test setup is ready. So make sure that your mount is on the center of your base plate. Coming to the experimental setup, so this is the operating system. So initially the emergency buttons will be on condition. I need to make sure that it will be off. If you just rotate it, it will come up and you can operate the machine. This is the start button. We need to press the start button, and there are two levers present in this. One is the load release lever and the other one is the load lock lever. And there is one more lever which tells you about the rate of loading from slow to the fast. For this particular experiment, we are supposed to do the rate of testing at 4 tons per minute. I release the emergency button. I am just locking the load and I am fixing it to the neutral system center. It's neither fast nor slow. And then we are going to run the machine and we'll make sure that the load at this particular thing will be 400 newtons. At 400 kilonewtons, we are going to stop the machine. When we are applying the load, so you should make sure that there's an axial load acting on this complete setup. What is happening here? The aggregate inside the testing cylinder is compressed with the axial force. After applying 400 kilonewtons of load, what we are going to do is, we are going to release the load wall. Rotate in the anti-clockwise direction to release the load wall. Once it is releasing, you are going to observe the settlement of this plunger. We are going to remove this entire unit. And you observe there's a crushing happened in this aggregate system. What we are going to do is, we are going to remove the top portion of the plunger. This is what you are going to observe, the crushed aggregate sample. So this sample we are going to sieve through 2.36 mm sieve, and we are going to take up the weight which is retained on 2.36 mm sieve. Take up the sample which is passing 2.36 mm sieve and weigh the particle passing 2.36 mm sieve. Note down the weight. The ratio of weight of sample passing 2.36 mm sieve to the ratio of original aggregate taken gives you the aggregate crushing value. Generally, it should be less than 30% if you are using for concrete mix or bituminous mixes. This completes your aggregate crushing strength test.
At MSR UAS, we spark your imagination unlike any other.